People have been doing this for so long. Humans stumbled into malting thousands of years ago. Some people say, what came first, beer or agriculture? Some people think that mankind discovered beer and it gave them a reason to literally put down roots, right? Be like, you know what, maybe I'll stay here and plant grain and, keep this, replicate whatever just happened here and keep that going. So it's kind of as old as civilization itself, and it's really cool in that way. We're a pretty specialized outfit in that Jeff fits a niche on the back end of the whole thing, where he's taking all the finished product and doing all the magic on that end to find out what customers want, distribute it out to them, work with truckers and God forbid the railroad to get stuff out to customers, and then I'm the middleman, more or less. I'm the one that's between the farmer and the finished customer. So I'm all the processing. I'm all turning raw grain into finished malted grains for customers. That's my whole life. We have a barley elevator manager who kind of helps coordinate raw incoming grains from our main elevator up by Fargo, but we contract just from individual farms too, and kind of bring it in from them. We'll bring it in from elevators out west, more further west, like in Idaho. Yep. A lot of that's rail, but some of it's truck. We'll bring that all in, and it's a big logistics coordination game around here. Me, it's a little more specialized. I'm just a farmer in slow motion in a lot of ways, because I'm growing grains, and I'm growing them in a very specific way to transform it into a raw ingredient, or into an ingredient for brewers. So that's kind of what I do. That's my specialty. I'm a grain chemist, more or less. Understanding how grain is from an agricultural standpoint, a commodity standpoint, but then from a chemistry standpoint, there's a lot that goes on in that grain that's you don't see necessarily. And that's kind of what I do. But I can explain the whole process for you guys and what it kind of means. I'll pull it down into more layman's terms, but it's a pretty incredible process, and it's nothing too scientific. I mean, it's very scientific, but when you peel it all back, we've been doing it for thousands of years. Humans have.
A little bit, where's the family originally from?
The family's originally from Germany. And in 1847, they immigrated to Wisconsin from Germany, Manitowoc. So the company originally started in Manitowoc, Wisconsin, and then in the 1930s, they moved here to Shakopee.
Okay.
Kind of moved the company west. This was intended to kind of be the new, latest and greatest kind of site to build the company. This was kind of more attractive. It was on rail. It was closer to barley fields logistically. It was on the Minnesota River. It was close to the Minneapolis Grain Exchange. It kind of had a lot going for it, as kind of to be the new flagship site. And so we've been here and kind of grew organically since the 30s. Yeah, so we can head out to the malt house. So all in back of us, all these silos, that's all raw grain storage. So that's all barley, wheat, oats. And there's all these segregations because we have all sorts of different varieties of barley, varieties of wheat, coming from different parts of the country, different farms. So we keep these all separate because they all process a little differently. They are biological. They all kind of have different little quirks or characteristics that's unique to their breeding, where they were grown, the weather conditions they were grown in. They all grow a little bit differently from me on the malting side. So we keep them all separate, kind of test them, see how they react, and then process them accordingly. So it's not a one-size-fits-all thing. That's my job. I'm the one that has to develop more or less recipes or unique processing parameters for all these different sorts of raw incoming goods, because it's an agricultural good, meaning that there is no consistency sometimes in agricultural goods. It's coming all based on growing conditions, field conditions, all those sorts of things. And it's up to us to identify them, process them the right way, because ultimately we have to make a consistent outgoing product from an inconsistent incoming product. And that's why
That's a good way to put it.
Get paid the big bucks, right? A big part of what makes us successful at what we do is kind of knowing, because this process can't really stop, right? That it's, once the grain is growing, it's pretty loud. We need to have redundancies to make sure that the process can't be interrupted. So like in front of you, this is Coda Energy. Coda is our cogen power plant. So Coda produces all of our thermal and power for our whole campus here. Basically, we can operate independently of the municipal electrical grid, producing all our own power here at Coda, as well as all the thermal that dries all of our grain comes from Coda. And Coda is kind of unique. It burns all agricultural waste. So it burns, most of it is bulk loads of oat hulls from General Mills and Fridley, and a little bit now from Quaker and Cedar Rapids.
Mill.
Yeah, so they grind up oat hulls, wood waste, like wood chips more or less, and some of our own chaff and dust from here. And they'll grind it all up into a powder in hammer mills and blow it into a suspension boiler and ignite it. And so basically it's like a controlled dust explosion. It's burning this agricultural waste, this biomass, and putting it through a big boiler and turning a genset with it. So we'll produce all of our power and then some. We can sell off to the grid if the price is right. And then all of our heat will produce thermal. We'll heat glycol with it. Glycol is more or less like a food safe antifreeze. And those big insulated pipes is actually glycol being pumped all throughout the facility. That glycol is like 260, 270 degrees Fahrenheit.
Oh my
It
God.
goes through big radiators, and that's kind of our instantaneous heat source for all of our drying operations. So we don't have to rely on any kind of direct fire or anything like that. Although we do have backup systems that kind of are able to come online if anything ever happened. We go down on maintenance sometimes, but for the most part, it's kind of on-demand, carbon neutral heat and power. So it's all great to have that redundancy.
Wow.
But if that ever went down, we could go on the municipal grid. We have our own wastewater treatment plant here on site. We can treat sometimes up to about 2.2 million gallons of water a day, because malting is extremely water intensive. But otherwise, you know, we have all these different redundancies. The warehouse you probably saw when we came out of the office, that's all a giant parts warehouse. It's nothing but spare parts for all of our machinery, because we just can't afford any kind of upset in the process. And you'll see when we look at the process, you'll understand malting's really like life support for living, growing grain. And if you can't afford to have that ever disconnect. So it's really a unique process.
Wow. So where are we going now?
So we're going to the top, to the steep floor. Malting really has three main steps: steeping, germination, and kilning. And steeping is really, we'll call it a hydration step. We're letting the grain intake water, just like it would in the ground when you planted it. It'll intake water, and that kind of kickstarts its growth, right? Life needs water. So the grain will uptake water, it'll wake it up from a dormant state, and it'll begin wanting to sprout. Germination's just kind of a fancier term for sprouting of the grains. The grain will begin to sprout and want to grow into a new plant, typically here a barley plant. And there's a lot of chemical changes that occur in the grain for that, because the grain's breaking things down, constructing new tissues, new compounds, in order to become a new plant. But a lot of these things are necessary to be used in the brewing process. And at the end, we'll do kilning, which is just a different term for drying. It's maybe a more specialized form of drying. You can think of it as a combination of drying and cooking or toasting. And that basically kind of arrests the process, slows it down, stops it, makes it stable, but also introduces a lot of flavor and color compounds that when you think about your favorite beer or beverage, a lot of those kind of toasty, roasty, biscuity, crackery, all these kind of, we would say, malty type flavor characteristics, but a lot of those like depth of flavors and some of those rich colors all come from the kilning process of the malting process. You know, barley would just taste not very good and would be very lightly colored and have no real like depth of flavor. This introduces all that kind of nice, deep flavor. All different sorts of malts that we make here, and they all have different flavor color profiles based on kind of what we do. And that's why your beers can be anywhere from really light, really mild and clean, a little darker, a little beefier taste, like say an Oktoberfest, something like that, all the way up to really dark malts can introduce like dark red colors up to like the black colors you see in stouts and things like that. Those are roasted malts and roasted barleys. So that whole gamut kind of is what the brewer has to play with when he makes his recipes. So it's quite the thing to manage.
Yeah, that's a great explanation.
Yeah. We typically start at the top, steeping's at the top, because we like to use gravity whenever possible. Because gravity is free, cheap, and very reliable. And we'll start at the top and try to use gravity to move everything down the process.
Smart.
The least grain legs we got to go through, the better.
Amen.
Because sometimes you got no choice. So one thing about these malt houses is they are temperature controlled and they are more or less pressurized because again, this is kind of a life support system for growing grain. You need to have the appropriate temperature so that grain's in a comfortable, stress-free environment. And we got to make sure we have airflow. So a lot of this is all pressurized to pull oxygen and air through the grain. I like to think that we're trying to simulate a nice North Dakota May day, perfect germinating and growing conditions for cereal grains. So that's kind of what we're trying to replicate in here. So yesterday afternoon, these tanks were empty like this, and they were filled with grain and water. And they were filled up to the point where they're at that overflow full of grain and water. And it's kind of a grain and water slurry. That mixture is roused with compressed air. You can see the nozzles in these tanks. They'll blow compressed air up through the tanks, move the grain around. And that's really important. It keeps the grain mixed. It makes sure that water's constantly touching the surface area of the grain, letting really even hydration of all the different grains. Consistency is key. It's the first step. If you're not consistent at the very beginning, you'll never make up for that later on. So you have to start consistent, maintain it till the very end. And we're just looking, barley's typically around 12%-ish moisture coming from the field. We want to bump that up. By the end of steep, we'll be anywhere 40 to 45%, depending on what we're trying to do. We're really just trying to hydrate so that embryo that's in that seed wakes up and begins to want to become a new barley plant. And then that'll kick off all these changes that ultimately are malting. Malting is, basically a very controlled form of the typical growth of a seed into a new plant. We're just harnessing that and doing it in a very controlled way that's going to allow it to become perfect raw material for a brewery. And we'll talk about that when we get into the germination side of things. But our main point here in steeping is just really consistent hydration of these seeds up to where we want it to be, and really maintaining a high oxygen, cool environment that keeps this grain in a perfect kind of habitable zone to want to sprout and grow.
How long will this grain spend time in here?
Just under 2 days. Underwater for about 12-ish hours, and then it is drained like this and periodically gets rained on for about another 30-ish or 24-ish hours. So they're all different depending on what we're trying to do. So generally that's kind of how it is. This water just keeps wetting that grain, letting it hydrate further and further. It also helps keep it cool. We have 6 malt houses here spanning from the early 30s or the mid 30s to this is the newest at 2016. And they're all a little bit different, which is great because me as the maltster, they all have strengths and weaknesses that I can cater to different types of production. They all do certain things well, and I can kind of move things around. It gives me a lot of flexibility. There's some customers that prefer the oldest malt houses because they have that bit of almost nostalgia and kind of vintage aspect to them, and that's what they prefer. And they have their smaller batches and things like that, So this is about 400,000 pounds of barley. 100,000 in each tank. So at the end of the day, this will be about 200 metric tons of finished malt. So we'll head to germination and we'll see. So these are built to hydrate the grain. But once the grain starts to grow, well, you want this to be out of there by then, because once the rootlets start to grow, they'll never come out of these tanks. So there's a window of just the right timing when the grain starts to want to sprout, but hasn't fully sprouted. You want to send them from these tanks down to germination. Germination is actually designed to handle the sprouting and growing of grain. So we'll head down there. Okay. We're at the germination floor.
Okay.
So Germination 28 to be exact. And coincidentally, it's right next to the kiln, so it works out pretty well.
Oh, wow.
Yeah. Steeping's the boring part. It's the important part, but it's visually the least exciting.
So can you explain what we're looking here and why are they kind of in these little
The
kind of
furrows?
Furrows, yeah.
Yeah. So again, this is germination. So those 4 tanks we saw up above, when steeping is complete and the grain has hydrated to the point where it is able to want to grow and sprout, we'll send it down into this germination bed, putting it into piles with this overhead conveyor. And then that machine, we can walk a little closer, it's the turning machine, because it'll travel back and forth along these rails. It's geared down significantly. It's turning the grain right now. It takes about 2 hours to make a single pass one end to the other. But those helixes, we call them, they're basically turning screws. They move and turn the grain, which does a couple things. One, it helps mix things. 2, it helps free and fluff up the grain, because if not, the rootlets would grow and bind together, and we'll have a 400,000 pound brick instead of light, fluffy grain. It can also add water to the grain and keep kind of bumping up hydration, and that water kind of promotes more growth. And ultimately, that's what's going to help us unload this at the end of the process. But we want to keep this nice, mixed, and fluffy. And this grain was actually put in this morning, so it hasn't grown too much yet, but it's just beginning to sprout rootlets.
Oh, yeah.
Yeah. Little rootlets. Like I said, it's still pretty early on. It's got another 3.5 days or so to go.
So it'll be sprouted a lot more than that?
Yeah, it'll have probably 1/2 inch roots on it by the time things are done, or 3/8 inch roots. It's got to be so loose because fresh air is coming in from that outlet there and being pulled by big house fans that are kind of the lungs of the malt house, pulling fresh air through the grain, pulling out CO2. This grain is outputting a lot of CO2 and heat and water vapor. It's 400,000 pounds of living, breathing biomass, really. And we got to evacuate out all that CO2, keep it cool and oxygenated. The more air we push through it, the cooler the grain gets. The less air we push through it, the warmer the grain gets. Like I said, the grain's producing a lot of its own heat. In fact, in the middle of winter here in Minnesota, we'll actually use the waste heat from the grain itself to heat this whole house. So more or less, we'll use the metabolic heat from the grain to heat our incoming air, and we'll keep this whole thing about 60 degrees in the middle of January just by utilizing all the heat that this grain's working hard trying to grow and become beer. It's huffing and puffing, so it's putting out a lot of heat.
Was that a wasted process that somebody thought to catch it, or is that just kind of a natural byproduct?
I mean, it's a natural byproduct of the process, is this heat, but I think a long time ago when people designed these houses, they knew that you could use some of that heat to reheat and add back into the incoming airstream and keep it warm. Additionally, we keep all this air humidified, so it's nice and kind of humid because we send the air through humidification sprays that keep it all nice and tempered and fully saturated. That way, when it travels through the grain, it doesn't dry the grain out. Mm-hmm. So again, it's a perfect environment, kind of life support, nice, habitable, stable environment for that grain to want to sprout and grow in. And it's just trying to become a new barley plant or a new wheat plant or a new oat plant. And it's just doing things that would typically be done in nature. That's kind of its natural, prerogative. It wants to start producing these rootlets and other tissues, and it's a catabolic process. So it's breaking things down. It's breaking protein down into simpler forms, but those simpler proteins are used by yeast when the yeast ferment it into alcohol. Those simpler proteins will be used like foam stability, so it'll create that nice head that's on a beer. It'll need food. It's not photosynthetic, it's not green. It actually breaks down some of the starches, which is what, all the grain is really a starch delivery device for the embryo. So all the starch, all that white is starch. Mm-hmm. It'll begin wanting to break that down into sugar to feed itself. So it produces enzymes that turn starches into sugars. Those same enzymes will be captured by the brewers when they use this product to break all that starch down into sugar during the brewing process. They call that mashing. And then all that sugar ultimately gets eaten by yeast and becomes alcohol.
Chris, could you explain what this machine replaces the manual process?
Well, many, many years ago, this process would be done, they called it floor malting. So you would spread the grain out on a big floor, and it'd only be about 6-8 inches deep because there was no fans to pull air through it, and there was no machines to mix it up. So people would pretty much go with shovels or big rakes and fluff and move it and try to bust it up, try to get fresh air into it. In the Industrial Revolution, they figured out you could make these a lot deeper if you use fans to actually force air through the grain, and then build machines to actually mix things up using, at that time, belts and steam and things like that. So now we're doing that. It's called pneumatic malting because we're pulling air through it. And these are technically called Saladin boxes. One of the first people to really popularize industrial maltings like this was a guy named Saladin. He kind of invented these mechanical boxes for making malt.
How many floors do you have of this?
Four.
Four
We have 4 germs here in this house.
Yeah.
But in general, here in Shakopee, we have 6 malt houses. House 1 being from September of 1936 is when it first came online, to this house, Malt House 6, that came online, and I want to say it was November of 2016. So we have 6 malt houses spanning almost 90 years of time and kind of iterations of malting technology. So 6 malt houses, 29 germination compartments total. This is 28. 29 is below us. That's our last one for now. And 8 kilns. This is kiln 8. The other kilns are in the other houses. It takes 4 days for this to kind of occur as it sprouts. Again, breaking itself down bit by bit, producing enzymes. It actually kind of breaks down compounds that make it rigid. That's why barley is really hard. As you guys know, when you chuck malt can be we call it friable. Basically, it means it can crush and crack and break really easily. Sometimes to a negative effect.
Yeah.
For the brewer, that's great because he can mill it really easily. It crushes and turns to a cracked form really easily in the brew house. If we did a poor job as maltsters and that didn't happen, the mills would be screaming and the beer would be really kind of viscous and not that great. So we need to be really diligent about breaking things down. We call it cytolysis in the business, but we break down some of these compounds, like beta-glucans are a big one, that allow it to be more useful in the brewing process.
Okay.
So those are my 3 big goals throughout this 4 days of germination. And then at the end, it's grown, it's met all these criteria, it's all good to go. Then we move on to kilning, which is the final stage. Like I said, kilning's kind of a hybrid between a dryer and an oven, because we're trying to dry it down, but we also want to kind of almost roast it or toast it like an oven would, produce a lot of those kind of flavors and things like that you would expect.
Woo! What is the temperature in here?
Hot.
Hot.
Yeah. But the reason it's so aggressively warm is because this malt is actually turning to sugar in the kernel, and then under really high heat, which is now, slowly becoming more or less like really dark caramel type flavored compounds. So this is a unique product. It's much more aggressive than a standard brewer's malt. But to get these really intense flavors, you have to be under these really intense conditions. It's probably about 185 degrees going on, and probably 125 or so coming off, but 100% humidity. And this is going to increase and increase until it's almost 195, 200 degrees Fahrenheit. So basically, you're pulling as much moisture off the grain as possible right now to dry it down, and then it'll get drier and drier and drier. And we can kind of sense that change in humidity and temperature, and we'll use that to step up our temperature or recirculate moisture back around and things like that. So that's kind of how we control this whole process. But we manipulate airflow, temperature, and humidity to produce all sorts of different color and flavors. That malt's a big spectrum of basically color and flavor. And you can go from the very light to the very dark. And the flavor profiles kind of change with that. This will be about 24 hours.
Oh, wow.
This is a long one because it undergoes this really high humidity, high temperature kilning. It just doesn't dry as fast. But this high humidity, high temperature is what ultimately lets this grain produce a lot of sugars, and then ultimately produce this like really dark, rich flavor and color.
Yeah.
So this will be what we call caramel 60. So if you guys ever truck this, you can smell it when we're loading the trucks across that whole half of the plant, because it smells like prunes, that whole loadout shed.
You can break men into sort of.
You, unless you're a special tour group, you don't go in there. Wow. A lot of people who live in Shakopee their whole lives never knew what goes on here. It's all, on this campus, behind concrete walls. People think we make, someone asked me where we kept the ice cream, because they malt, they're like,
Malt,
oh, malt.
yeah,
they're like, oh,
right.
you're the ice cream factory. And
Yeah.
it's like, oh, not really.
How many generations does Rahr have?
5.
This is the
So
fifth
Willie, who's our CEO, he's the 5th generation.
Okay.
And you can almost say 6th because Blake, his son, is kind of hanging out. He's a young kid. He's like 22 years old, so he's just kind of hanging out. He likes to work in the malt houses more than do the business stuff. But really, it's about 5. Willie's the 5th generation Rahr to own and run the business, and he's you see him in the office almost every day.
But their systems, I mean, that ends up, there's moving all the way over there. I mean,
yeah, so that'll be basically the malt leg that'll send it up to go to, so it's all belts that take the malt from here all the way to Jeff, to your loadout. So we have belts that take malt all the way from all the malt houses, centralize it to the malt elevator where that finished product is stored. Some customers are pretty vague, like we'll ship trucks right across the street to BSG, to that warehouse, which is where we bag everything for smaller customers. Or we'll send out to kind of middle customers. You guys will go to New Glarus in Wisconsin, or to Summit or August Shells here in Minnesota, or to the transload stations we have. Or we'll send rail car if we're going way out somewhere, So it's just depending on the size of the customer, can they take bulk, and how far out they are, or it's going across the street to be bagged into 55-pound bags, and then those are distributed in LTL trucking to all sorts of breweries. So we have the biggest breweries in the whole country. You can probably think of who they are. And we have every little tiny guy in every small town too. We have thousands of brewing customers, from little homebrew shops, little neighborhood, brew pubs, up to
you serve them just the same as you do the big boys.
all of them. Yeah. Yep. It's just how they receive it. Some big boys get it in rail cars. Some guys buy a bag from a store. We still have some 24 crop that we're working through, some 23 crop. Back in the early 2020s, we had a really, really good year, and so it kind of pushed all of our like that growing year went into the next year. Some of it into the next year. Well, then COVID happened and beer consumption dropped big time. So then we had a great growing year growing barley. But then when there wasn't anybody to buy it, customers were dropping.
What's the percentage of barley that goes out of here, malted barley that goes out of here on truck versus rail?
So we'll ship 65 rail cars a week to 45 trucks. So
Can he view it from up top?
Yeah. Yeah, there's a catwalk up there. Yeah, so this is our office. This is where all the magic happens basically. But truckers show up. They can either call us on 25 on the channel. They come and check in at the window. That was one of the best things that COVID did. Put a window in a door.
Kept us from coming in here and loitering.
Yep, kept truckers from coming in and telling us about how they don't like that Peterbilt store or this place.
Yeah.
And,
We don't like it because you got to tap on, nobody here, you got to tap on the window to get your attention.
Yeah, well, and you kind of feel a little bad because, they don't talk, well, I mean, they're on the phone, but truckers just go a long time without human interaction.
So when you see you, they
So
want to
they're like, oh, people.
Yeah.
And we're like, we're busy. We got stuff going. So yeah, the truckers come in and he'll enter in all the information on the computer. Mm-hmm. And basically what he does is he commits it to our CompuWay dashboard. And then the CompuWay dashboard communicates with the CompuWay bulk scale system. Yep. We load it in 4,200 pound drafts. And then as it gets towards the set point, it'll change that set point to a lower value. And we can do adds as low as
500 pounds up to 5,000 pounds if we need to, just to top off. Like when we load rail cars, it'll like auto load the rail car to 180 or 200,000, and then we can top off the last 5 to 10,000 pounds just using manual adds to make sure that we're getting as much in there as possible.
Wow.
Because it can vary, but depending on the moisture of the malt, you can get more in or less in. Different varieties that we send out of here also changes. Like a higher color malt has less moisture, it's a little bit lighter, so it takes up more volume with less weight. Then we make some dextrin malts and different things that are heavier, so they take up less room but more weight. So the guys have to kind of change that based off of what we're loading, and then even where we're going with it. Some of the drivers can only haul 48,000 pounds or 50,000, and they need 23 of it in the front, 27 of it in the back because they got a heavy cab, or whatever. So we can change all that because the trucks come in. We can add set points to them, have 2 set points or whatever to make sure that we get what they want and the side that they want.
And Garland was, so he was saying this isn't just microbreweries, but you're delivering to large. I mean,
Yeah.
There's stuff getting, and I know that'd be more rail, but
Yep.
this is going to some of the big brewing companies in
Yeah.
the U.S.
So Anheuser-Busch, Malt and Coors. We go to Boston Beer. We go to Constellation Brands, which is Corona and Modelo.
I guess I always thought Anheuser-Busch was, they own that process, like of contracting
Start
the
to
farmer,
finish, yeah.
start to finish.
They
But you're-
have, yeah.
They have?
Yeah,
Okay.
So they actually ended up shutting down their Moorhead, Minnesota malt house this spring, and we took over that volume from them.
Okay.
So it was just, it got to a point where it must not have been feasible for them to continue to run if they could work with us to get us to do it. So yeah, there's been a lot of malting facilities that have closed, especially since COVID, just because beer consumption's down. People are drinking a lot more of the RTDs, like the ready to drink things, the Jack and Coke in a can.
Somebody told me the CBDs
Seltzers and CBDs, yep.
have changed.
Yeah,
a lot
people are
too.
drinking that stuff. It's funny because they think that that's a healthier drink for you, but it's still 100 calories and 5 carbs, in a seltzer and something light, which is the same as what a Busch Light is. So it's not necessarily healthier. Maybe people like to mix vodka with seltzers more than they like to mix vodka with beer, but yeah, just in general, we've noticed that younger consumers are looking for more of the spirits because you get more bang out of less buck.
Just like the younger generation is not smoking or vaping.
Yeah, yeah, yeah.
Kind of the same.
Yeah,
it's a shift in.
It's money's tighter. Things are more expensive. Kids aren't necessarily getting out into the world working. You see a lot of kids going on 6-month not vacations, but just graduating high school and going to Europe for 6 months, and it's like I didn't do that.
I didn't either.
Like, yeah. So it's a lot different now, and just like I said, in general, beer sales are down.
I was told that at one time this is the world's largest malt house. Is that?
So we can malt the most volume on one campus out of any malting company in the world. So there's larger maltsters than us, like overseas, but as far as being able to make as much at one campus, that's us. So typically we're 2.5 to 3 million pounds a day. We'll load 14 rail cars a day and 10 trucks, give or take a few.
If you don't mind explaining that process one more time. So
barley's grown out northwest Canada, comes into you all. You have a contract with the farmers. In simple terms, how does that process work?
Yeah, so basically it goes from we have contracts with farmers in Montana, Idaho, the Dakotas, and so they'll grow it, and then they'll take it. They'll either hold it themselves or they'll take it to country elevators. And then we have a main elevator in Taft, North Dakota, or Hillsboro. It's north of Fargo, right on 29. And there they bring the barley in, they grade it, and they bin it according to variety and protein level. So then from there, Scott, who runs our barley elevator, he'll order the barley down here based off of what I tell the production guys that I need. So kind of in reality is the breweries are a customer of mine. The malt houses are who I order from. The malt houses order from Scott. Scott orders from the barley elevator up in Taft. So, but ultimately, I'm the one who decides what gets made here, based off of my inventory and what I'm shipping. So every week, actually, we just did it today. Every week we get together, and I tell them I need X amount of this, X amount of this, X amount of this, and these are the specs that I need you to shoot for, because every brewery has certain analysis that they're looking for. Colors, beta glucans, enzymes. Enzymes are what end up helping in the brewing process with getting the conversion of the sugars with the yeast and all that. So just to keep it kind of simple, I guess, to explain it that way. Yeah. So then Chris, he's the senior manager of malt production, he helps the guys get the recipes written up so that when the barley's steeped into the malt house and it goes through the process, it can target for the analysis that I need to make sure that I can ship it out of here within spec. Okay. And so, since every piece is a living thing, it changes. If every piece came out exactly the way they wrote it up, I wouldn't have a job, because we could just put it in the bin and ship it out. But so we have 137 bins that we can put malt into. So like this is the original, we call it the original bins. That was built in 1956. And then we've got the old annex there, which was an addition to the main malt elevator. And then we also have what we call a new annex on the end. And so like like a big bin like this can hold about 36,000 bushels. And then a medium one can hold about 18, and a small one holds about 9. And from there, we print these tickets. These tickets represent the different levels of malt in that bin. So then when I go into the program that I use to blend, I just have to know, because it gives me a bin average. Sometimes the bin average looks really, really good, but there might be something that's lower in color and something that's higher in color that's making that average look good. So for me, I have to know where I'm at within those bins, and to do that every day, every shipment that goes out of here has a sample tied to it. That sample goes over to our lab, and the lab analyzes it. And then the following afternoon, I get a report of how everything turned out. Typically within a month of it being steeped in, it could be at a brewery being used. So basically the trucks back in. They have to back in because of our progressor. If they drove through, then their tires could get caught on our progressor. But before the guy hits start, he looks down to make sure the hoppers are shut and make sure the truck's clean. Okay. And then on the order screen over here, it says doubles. It says DUT for doubles trucking. So then we can communicate with that loader down there through the CV. So, hey Chad, you can give me the green light. So then once that turns green now, I want to make sure that all my gates are set the correct way. We're all good to go. Truck's clean and gates closed. So I just hit start here, and you'll hear right behind you there's a sampler. So don't let it startle you. But once the flow of malt comes down, then it takes a series of samples over the course of the it comes out like this.
Holy smokes, that is fast.
Yeah. So the scale, like I said, the scale gets to 4,200, sees it, drops it. Once it's empty, it shuts. The garner above it starts loading it again. So everything's good. So I hit start again. So now we'll load the rest of the 25,000. So he's only taking 48,000 for this load total. Typically with hoppers, we can go 50 to 52. Yeah.
You look rail in the same bay.
Yep, same right here. Yeah. So the rail comes out of the same spout, and we load 2 at a time. So we can load 2 rail cars in about 25 minutes, 30 minutes. And we load a standard size rail car, and we load a jumbo rail cars. Yeah. Yep, you're all good. You can pull out and tarp up.
Thanks, sir.
We can head out here.
Okay.
So this is the malted barley. We can take it in there too if you want. But I'll grab the stuff that we just loaded.
How's this so different from regular barley?
So regular barley is shinier, and it has a different color to it. It's usually lighter colored because this has been through a heat process, you know. But basically, like barley, you can't crack open, but with this, you can crack it like that. If you eat, you can eat it. It's sweet, like sweet grain, like cereal grain almost. But yeah, so now this goes to the lab. It's got on the ticket here, it's just got, you know, what day it was loaded, what scale, what time, the transport unit, date, customer. It's going to Minhas. The blend is a 2J, which is like the Rahr standard 2-row. What blend ID was used, and then what trailer. So doubles transport trailer 76.
After you load a food grade load, we have to seal this to ensure the integrity of the load from shipper to receiver to make sure that the product is not tampered with in any way, shape, or form. And it's pure coming out of the shipping facility and right to the receiver. They have these metal braided seals that are pretty tough to break. And if you break it, there's no putting it back together. So they know that one of these is broken when they get there, loads are jacked in.
Yeah, and then we have a camera that points out here so that if there is any discrepancies, the brewery can call and we can send them video of the person applying the seals. But yeah, when they sign that paper, it says that they're going to seal it up and that they're now responsible for it. So we had one guy one time didn't seal up, forgot to before he got to the brewery. He owned a 50,000 pound load of malt. So, because we're not going to take it back either, because we don't know what happened to it.
You say $50,000, 50,000 pounds. What's the dollar look at?
Probably 15,
Something like that.
Good shot.
Yeah. Welcome. You're very welcome. People just don't quite understand what all goes into a, you know, what all the agricultural inputs to a beer, and same for a lot of foods and everything else in life. Cotton in your shirt, you know, ethanol going in your vehicle, biodiesel from soybeans, just ink that stuff's printed on typically comes from soy. Like, I know it's changing a lot. There's a lot of families involved, you know, it's a lot of cultural stuff involved. People probably don't understand, man, farming really runs in your blood pretty heavy.